Hi, my name is Thayalini Balasubramaniam, metric card number TC1913. So today, my group members and I are going to be discussing plasma arc welding. Alright, so as an introduction, plasma arc welding is an arc welding process similar to gas tungsten arc welding. Arc plasma is a temporary state of gas. The gas gets ionized after the passage of electricity current through it, becomes a conductor of electricity. In ionized state, gas atom breaks into electron and ions, and the system contains a mixture of ions, electrons, and highly excited atoms. Definition and concept. Plasma arc welding is an arc welding process wherein coalescence is produced by the heat obtained from arc set up between a tungsten or alloy, tungsten electrode, and the job. Coalescence is the union of colloidal particles into a group or larger unit as a result of molecular attraction on the surface of the particles. The process employs two inert gases. One forms the arc plasma and the second shields the arc plasma. Principle of operation. So plasma arc welding is a constricted arc process. The arc is constricted with the help of a water-cooled small diameter nozzle which squeezes the arc, increases its pressure and heat intensity, and thus improves arc stability, arc shape, and heat transfer characteristics. Equipment and the function. So current and gas decay control. It is necessary to
Of Siam, ID number TC19090. Today I'm going to explain about how does plasma arc welding works. A plasma is a gas which is heated to an extremely high temperature and ionized so that it becomes electrically conductive, similar to GPAW, which is also known as TIC. The plasma arc welding process uses this plasma to transfer an electric arc to a workpiece. The metal to be welded is melted by the intense heat of the arc and fuses together. In the plasma arc welding torch, a tungsten electrode is located within a copper nozzle having a small opening at the tip. A pilot arc is initiated between the torch electrode and nozzle tip. This arc is then transferred to the metal to be welded. By forcing the plasma gas and arc through the constricted orifice, the torch delivers a high concentration of heat to a small area. With high-performance welding equipment, the plasma process produces exceptional high-quality welds. Plasma and the next one is okay. Plasma gases are normally argon. The torch also uses a secondary gas, argon, argon hydrogen or helium, which assists in shielding the molten weld further, thus minimizing oxidation of the weld. There are two types of plasma arc welding. First is, we can see in this picture, the first one is transfer arc and then non-transfer arc. For transverse arc, the arc is struck between the electrode negative and workpiece positive. The workpiece is a part of the electrical circuit and heat is obtained from the anode spot and the plasma jet. Therefore, higher amount of energy is transferred to work. Used for high-speed welding so thicker sheets can be welded. For example, to weld the ceramics, steels, aluminum alloys, copper alloys, titanium alloys, nickel alloys, higher process efficiency. No transfer mode. Arc is struck between the electrode negative and the nozzle positive, thus eliminating the necessity to have the work as a part of electrical system. The workpiece is not part of the electrical circuit and heat is obtained from the plasma jet. Therefore, arc process produces plasma of relatively low energy density. The plasma arc torch may move from one workpiece to other without extinguishing the arc. Less penetration is obtained, so thin sheets can be welded. Less process efficiency. This is video for how the plasma arc welding works.
In plasma arc welding, metal coalescence is produced by a constricted arc made up of a high-velocity stream of ionized gas called a plasma. In most plasma arc welding operations, the plasma jet is generated by heating the orifice gas in the torch polenum chamber to a plasma and forcing the plasma to exit through a constricting nozzle or orifice. Partial shielding is obtained from the plasma and is supplemented by an auxiliary shielding gas. Auxiliary shielding gases used include argon, helium, or mixtures of argon with hydrogen or helium. Because of the constricted arc, the heat energy of the plasma stream is concentrated and extremely intense. This permits deep penetration, narrow welds, and rapid welding speeds with good arc stability. Workpieces can be joined with or without filler metal. Plasma arc welding can be used to join most ferrous and non-ferrous metals, including extremely thin materials such as foils. Plasma arc welding equipment cost is high, however, so the process is often limited in its application.
Welding. Plasma welding has three different modes of operation that are determined based on the current, plasma gas flow rate, and orifice diameter. These are microplasma welding, high current plasma welding, and keyhole welding. The microplasma mode, ranging from 0.1 to 15 ampere, allows the welder to operate with a longer arc length in relation to GTAW and no possibility of touching the electrode to the work. At low welding currents, the arc remains stable, making it suitable for welding very thin materials in delicate situations. The microplasma mode can be used for tools and die work as well as mold repair. Arc length is varied up to 20 mm. And next one is the high current mode, also known as melt-in mode, typically ranges from 15 to 400 amperes and is used for precision and high weld quality operations. It also used in overlay applications such as hard surfacing. The protected electrode inside the torch improves the welding geometry and penetration control. This mode also provides a reliable arc transfer and arc stability. However, this technique can only be used in conjunction with larger orifices and precise plasma gas flow rate control to avoid burnout of the plasma tip. The tungsten in the torch can be set in two ways in this mode. In most cases, the electrode is set flush with the end of the tip. This gives a soft arc much like a GTAW arc. The second way is to recess the tungsten inside the plasma tip. This can vary in distance but is not to exist the recommended setting in the book. Recessing the tip provides more of a column-type arc. And the last one is keyhole welding. In keyhole mode, from 100 amperes to high and higher, the tungsten is resisted in the tip and the current level and plasma gas flow are increased. This mode generates a powerful plasma arc very similar to a laser beam. During welding, the plasma arc passes through the metal material, producing a keyhole through the part with the molten weld pool flowing around the keyhole to form the weld bed. This provides complete penetration to the thickness of the part in one pass. In very thick material, a joint design is needed to reduce the thickness of the material, and multiple passes in the non-keyhole mode are needed to fill the joint. The next one is control system. The control parameters for control system is isolation modules, followed by embedded controller and HHI terminal. For welding process, the control parameter is plasma welding power supply, plasma welding torch, and followed by pipe welding platform. That's all. Thank you.
So, my name is Punita Malar Ravi, TC19075. I'd like to present about the advantages plasma arc welding. So, what are the advantages of plasma arc welding is first, ability to cut all the metals. So, no matter what kind of metal it is, whether it's rough, thick, or anything, it can cut. Next is it control better control of arc. It allows better control of arc. So as you can see the picture that shows up, when it cut the metal, it can control the arc and the shape. So next is due to the higher heat produced and the plasma jet allows faster travel speeds. So it can allows a faster travel speeds. Next is high heat concentration of plasma allows keyhole effect which produce complete penetration with a single pass welding of many joints. So usually when we use the plasma arc welding, it provides complete penetration with just a single pass welding of many joints. So next is it provides more freedom to absence and control the weld. Next is it can cut metal even faster than oxy-fuel welding. We know that oxy-fuel welding is a faster welding we can use for any fast to make a faster object, but this plasma arc welding is more faster than oxy-fuel welding. So next is useful for semi-automatic and automatic processes. So what is semi-automatic means manual welding with the equipment that automatically controls one or more welding conditions. So this plasma arc welding is useful for that. So next is it leaves the narrower curves. So uh, the picture also shows the narrower curves. So finally, the process is very clean and fast when we use plasma arc welding. So next we are going to see about the disadvantages of plasma arc welding. So basically, a plasma welding equipment are very expensive. Next is it requires specialized training and personnel to perform the operation because normally not everyone can use the plasma arc welding. The people who use the plasma arc welding need the specialized training. Next is higher noise produced. Furthermore, needs high power electrical equipment, gives out ultraviolet and infrared radiation. As you can see from the picture, when we when we use the welding, it produces ultraviolet and infrared radiation. So next is can weld only up to 25 millimeter thickness. Finally, more chances of electrical assets because we use electric to use this welding. So more chances of electrical hazards. So next I would like to present about the precaution of plasma arc welding. This is the important things that we should know when we use welding. So first of all, must use face shield with glasses under it. Next is protective clothes, which is gloves, welding safety shoes and welding helmets, flame retardant clothes, cuffless trousers, remove flammable things from pocket before cutting such as butane lighter or matches and so on. Next is noise level. Plasma cutting systems can generate a noise level up to 120 dB during the high amperage cutting operations. So always wear earplug during the cutting process. So finally is toxic fumes and gases. So plasma arc welding systems can produce toxic fumes and gases that can affect our oxygen and serious injury. So always use it in a well ventilated area and don't do the welding process in locations near degreasing, cleaning or spraying operations. This is very important thing when we use this plasma arc welding. So next we are going to see about the applications of plasma arc welding, which is where we can apply or where we can use this plasma arc welding. So first is marine and aerospace industries. Next is ship construction. And third is weld pipe. So next is automobile and railway. Finally, tubes of stainless steel. So next we are going to see about the short name of plasma weld. What are the meanings of the each name, each letter? So what P stands for is protected electrode, L stands for low amperage welding capability. So A stands for arc consistency and gentle arc starting produce consistent welding, which is a perfect welding. So S stands for stable arc in arc starting and low amperage welding. So M stands for minimal high frequency noise issues. And again, A stands for arc energy density reaches 3 times of GTAW. Higher weld speeds is possible. So what is 3 times of GTAW? What is GTAW means? Gas tungsten arc welding that uses non-consumable tungsten electrode to produce the weld. So next is weld. W stands for weld time as short as 5 milliseconds, which is 0.005 second. So E stands for energy density reduces heat affected zone, improved weld quality. L, L is length of arc benefit due to arc sheet. So D stands for diameter of arc chosen via nozzle orifice. So nozzle orifice most commonly used as flow measurement devices as well as control the flow. So finally, the conclusion of plasma arc welding is in the latest field of technology respect to welding and machining, plasma arc welding and machining have a huge success. So due to its improved weld quality and increased weld output, it has been used for precision welding of surgical instruments, to automatic repair of jet engine blades to the manual welding for repair of components in the tool, die and mold industry. So, but due to its high equipment expense and high production of ozone, it's been outnumbered by other advanced welding equipment like laser beam and electron beam welding. So, thank you from our group.